There are two types of load balancing. We have application level load balancing and also we have network level load balancing. Application level load balancing. Load balancing is implemented between tiers and application stack and is carried out within the application. It's used in scenarios where applications are coded correctly, making it possible to configure load balancing in the application. Designers can use open source tools with DNS or some other method to track flows between tiers in the application stack. Network level load balance includes Dns Round-Robin, Anycast, and Layer 4 to Layer 7 load balancers. Web browser clients do not usually have built-in application layer redundancy, which pushes designers to look at the network layer for load balancing services. If applications were designed correctly, load balancing would not be a network layer function. So let's zone in on a few network layer load balancing mechanisms. DNS Round-Robin load balancing. The easiest type of network load balancing is DNS Round-Robin. It entails a DNS server that keeps track of application serverability in some way. The DNS control plane distributes user traffic over multiple servers in a round-robin fashion. For example, a workflow may go like this. The client asks for an IP web server and DNS replies with an IP address using some random order. It works well if the application uses DNS. However, some applications have hard-coded IP addresses, and in these scenarios, you cannot rely on DNS load balancing. DNS load balance also requires low TTL times, so the client will ask the server often enough. Generally, DNS load balance works well, but not with web browsers. There have been so many attacks on web browsers, and browsers now implement security known as DNS pinning. DNS pinning is a method whereby you get the IP address of a server, and even though the TTL has expired, you ignore the DNS TTL and continue to use the URL. It prevents hackers from spoofing DNS records and is usually built into most browsers. DNS load balancing is perfect if applications use DNS and listen to DNS TTL times. Unfortunately, web browsers are not in that category. IP Anycast provides geographic server load balancing. The idea is to use the same IP address in multiple POPs. Routing in the core will choose the closest POP, providing routing for that client to the nearest POP. All servers are configured with the same IP address, usually on their loopback address. If the same IP address was configured on their LAN interfaces, then ARP replies would clash. You can use any routing mechanism to generate equal cost multipath to the loopback address. Static routes can be used based on IP-SLA, or you can use a dynamic routing protocol such as OSPF between the servers and the router. A request comes in the router with load balancing based on the 5 tuple, and obviously not load balancing based on the destination address and port number, as this will always be the same. Load balancing is usually carried out on the source IP address and port number. The process takes the 5 tuple and creates a hash value, which creates independent paths based on that value. This works well for UDP traffic, and this is how the root servers work, so it's a good design for DNS server load balancing. It works well for UDP as every request from the client is independent. TCP does not work like this, as TCP has sessions. As a result, it's recommended not to use Anycast load balancing for TCP traffic. If you want to load balance TCP traffic, then you need an actual load balancer. This can come in the form of a software package such as HA proxy or a dedicated virtual or physical appliance.